Hello and welcome to this instructional video on the instant energy calculator for upstream devices less than 125 amps, which is among a suite of 10 tools that are designed to allow a competent electrical engineer to determine the severity of an arc flash incident. My name is Mike Frayne and I'm the creator of the European Arc Guide and the author of the book The European Arc Flash Guide. To access the calculator, select the Calculators tab and then Instant Energy Devices below 125 amps. If you select Expand or Collapse, you'll be able to provide preset configurations, and this will also give you access to the comprehensive guidance on how to use the calculator. Please note that the calculator is valid for European three-phased harmonised voltage of 400 volts, which is the usual LV system distribution voltage used in Europe. Please read the calculator instructions for limitations. Most fuses and circuit breakers that are 125 amps or less in Europe provide protection against arcing faults. But this is where care is required, as there can be fairly high levels of instant energy, even below ratings of 125 amps. So, the calculator follows the principle that a calculation is made to determine the minimum fault current to operate a circuit breaker or fuse instantaneously. It will then return the maximum instant energy at a selected working distance for instantaneous operation, and also where this criteria does not exist. The first field is electrode configuration, and you can learn all about configurations from the instructions and more detailed in the guidebook. As can be seen in the diagram, the configurations are VCB, VCBB, HCB, VOA and HOA, and basically denote vertical or horizontal conductors in air or constrained in a box. We'll use VCBB for our example, which denotes vertical conductors that are terminated into an insulating barrier. For the sake of simplicity, there are no enclosure dimensions with this calculator, so the results will be conservative, and a more accurate figure can be obtained if you use the instant energy calculator, where enclosure dimensions can be entered should this be found to be necessary. The second field is the upstream protective device, and as you can see, it'll allow for results for most common types in use in Europe, and these include the DIN NH and BS88 types of high rupturing capacity fuses, and also miniature circuit breakers to EN60898 and EN61009-2. We'll choose a Type C EN60898 MCB. In the next field, you can select the current rating of the protective device, which is from 32 amps up to 125 amps. We'll choose 100 amps for this example. The next field is the working distance, and the drop-down menu gives a choice between 305, 450, 600 and 900 millimeters from a possible arcing source and the torso and head. Be aware that the hands can be closer to an arcing source. There's much information about distance in the guide, as the relationship between distance and severity is exponential, meaning large changes in incident energy for small changes in distance. In this case, we'll use 450 millimeters. If you press the Submit button, you can see that there are two results given. The first is normal instant energy in calories per square centimetre, which gives a value of instant energy for the configuration, working distance and rating chosen, where the prospective short-circuit current is high enough to allow instantaneous operation of the device. The second value is maximum instant energy. This is a value of instant energy for the configuration, working distance, and the rating chosen that could occur at or below the value of prospective short-circuit current that would be required to allow instantaneous operation of the device. A 2-second maximum cut-off time is applied, which is explained further in the instructions. Finally, the calculator gives a figure of prospective short-circuit current for where the normal instant energy or the maximum instant energy can be used. In this case, the value is 1.5 kA and is a prospective short-circuit current above which the protective device will operate instantaneously. So if the actual prospective short-circuit current is equal or more than 1.5 kA, then you can use the value given by normal instant energy. Otherwise, use maximum instant energy. So to be clear, if the prospective short-circuit current is above 1.5 kA, then you would use a normal instant energy level of 0.69 calories per square centimetre in this case. Or if it's 1.5 or below, you would use the maximum instant energy, which is 4.2 calories per square centimetre. I do hope that you enjoy using this calculator in the field, perhaps on your phone or tablet or PC, and that you find this and the guide to be a valuable resource to discover and manage dangerous levels of electrical instant energy in the workplace. Thank you for your time.